So there's my answer right there. Again, a lot of you didn't draw a picture. Shame on you. Draw a picture. It helps you visualize. Okay. For your homework, could you handle 37 and 39? Okay. So that's 2 problems on homework. Stare at these. Okay, it's phrased a little differently, but we've already done a problem like this as well. Okay. Like number 8. Could I draw a graph? Looks something like that. At -2. Can you give me the y value? You get -2? Okay. So did I draw it well? No. But can I redraw it well? Let's start that all over again. Okay. And my point is at -2, 2. Okay. Where am I going to attach the tangent? Yep. Can I attach this tangent? Okay. Now, who do I want x to be? And it's buried in the right side. I need the differential, whatever that means, of x. So delta x or dx needs to be what? 0.1. So if x was 1 and dx is 0.1, who's my new x? Move it off 0.1. Oh, wow. Sorry, what's my x value? Sorry. -2. Move off 0.1, what do I get? Okay. Since it says dx is positive, which way am I going? To the right. So I want, right there, I want x equals -1.9. Which would mean I would need to do y equals 6 minus 2, -1.9 squared. Yuck. Do you agree? But could you already do the tangent line and plug in -1.9? Is it basically the same question? Okay? So could you do 7 and 9? Okay? They're kind of showing the same question in 2 different ways. This one's saying this. Do you know what the function is? Who's the function? Y equals x cubed. Who are you going to attach to? Who's the tangent line going to attach to? X equals, and I need to plug in 2.99 into that tangent. Over here, it says, here's where I attach, and I need -2 plus 1 is -1.9. That's the guy I want. Is it the exact same question, just kind of rephrased? Okay? You guys okay with that? Cool. Okay. There we go. Here's 26. I'm going to show you how to do this one. Here comes a word problem. If you want, you can write it down. That's fine. I'll pause it. Okay, so this is on page 236, number 26. Okay, what's the area of a circle? That's worrisome. Okay, so that's pi r squared. It's not 2 pi r. That's circumference. Learn it. Okay? Okay. This guy here. Who has the air there? 1/4 of an inch. Who am I measuring? Give or take 1/4 of an inch. The radius. So could I call that, move it a little bit. Can I call that dr? Because that's the little moving of r. And you can call that 1/4. Okay. Now, for the next 2 steps, you might have a question, but let me just do the next 2 steps and then you can ask. let's take the derivative with respect to time, okay, our implicit stuff. So anytime you have a variable that's not t, what do you have to say? Like with the a, what are you going to say? dA dt. What about the r? dr dt. Okay, so I would have dA dt equals 2 pi r dr dt. You guys okay with that? Okay. So if I somehow told you that dr dt was changing at 1/4 an inch per second, who would I have? If I said 1/4 an inch per second, who would that 1/4 be? dr dt. But did I say per a unit of time? No. So no units of time. Huh. No units of time. I'd like to get rid of if I have no units of time, I don't want time. I want to get rid of it. Is there any clever multiplying that you could do? Multiply by who? dt? Okay. What happens on the left? Cancels out. dA equals 2 pi r dr. You guys okay with that? Cool. And the whole question is, basically, what's my give or take on the circle? So what am I asking for in A? This whole question's asking for, I want who? If I want, basically, what is A off of? What's A give or take? What would you write that as? I want who? dA. I know what dr is. When I measure my circle, I'm off by 1/4 of an inch. That makes sense? Like in real life, you can't always measure perfectly. But I can at least say, I think I'm off by like, 1/4 of an inch. So, if I want dA, go plug in. Here we go. dA equals 2 pi. dr I at least know is 1/4. Did it tell me who my r was? 16? And right there is r equals. So dA is plus or minus 8 pi. I just threw in a plus or minus because if I measured r short, 1/4 of an inch, would my a be short? If I meant my r a little bit too big, do you agree my a would be a little bit too big? So, I mean, if you want, could you have done right here, what is dr? Plus or minus, right? Because it's either one way or the other way. You guys okay with that? Which is about, I don't know, 24 point something. Wow. If I'm off a little bit on R, I get way off on A. That's huge. Okay? So I think R is 16, give or take 1/4 of an inch. So basically think of this. If I draw 16, could I also draw one that is 16.25? So that would be dr equals 0.25. Could I also draw one that is 15.75, which is dr is negative 0.25? You guys okay with that? So that little change in r did what? Huge change in where? A. So maybe this piece here, do you agree if I did the blue, I'm not grabbing this piece? guys agree with that? Oh. And if I did the red, do you agree I'm grabbing too much? You guys okay with that? So basically I'm saying ish, yellow off. What's yellow off by? Or sorry, what's what is that? That's blue circle. Blue circle is off by what? 8 pi? Negative 8 pi. And that's basically... no. It's going to turn a different color. What do? Get away from me. And, yeah. Basically, it's off by about 8 pi, which is like 24 units squared. Okay? And if I did red triangle, red circle is what? Positive 8 pi. Who's okay with that? Know where I said ish? Blue isn't really off, or sorry, this is not really 8 pi. The yellow is not really negative 8 pi, but the average of the yellow and the blue is what? 8 pi. Okay, that's why I said ish. And you could say this. Average of my underestimate and overestimate is 8 pi. Okay? Yep. So that's where it doesn't make sense. that line doesn't make any sense at all, the blue line. It doesn't. But the next line does make sense. That's where I kind of need you to accept it. The dt doesn't make sense. Why are we doing implicit? There's nothing about time in this problem at all. Why? Because when I have dA dt and dr dt, can I get rid of the dt? Are there always going to be a dt on both sides? So could I always multiply by dt and get rid of it? Now does the green line make sense? Okay? Goes okay with that. Here's another way. I'll give you another way. I don't care. What about this way? This way might make a lot more sense to you guys. Let's take the derivative in terms of dr. Would that make more sense to you? Instead of randomly throwing in a time? Is that just a normal derivative? Okay. So, what do I get on the left? dA over dr. Derivative? Do I need to put anything there? Because I could if I wanted to say dr over dr. What happens with that dr? Goes away. Let's do this way. This makes more sense to you guys. What could I do? There we go. Let's do this way. I always like going easier for you guys. Is that better? Do you get the same equation? Do you have to worry about t's anymore? Cool. Let's just stop on the t's. Whoop-de-doo. Okay? Okay. What does second question ask? You did everything on A. How do you approximate percent error again? Yeah. Okay. Expected minus approximate all over expected. So for my percent error, and we've already done this, it was expected minus approximate all over expected. Did I ever plug in to get the real circle? Have I ever gotten the real circle for you yet? No. And I can avoid by getting the real circle. Let me ask you this. Who is that? The expected guy, take away the approximate guy. What am I off by? That's what it's asking. What am I off by? D who? dA. This is just dA. So, and who's the expected? How would you write the expected? Who is he? What circle do I want? 16. So I want A of 16. Okay. So I got 8 pi all over pi 16 squared. Oh. 1 over what? Or give me a decimal. That's fine. The pi is canceled, but don't type in pi. 1/32, which is, what's the decimal? One more time, sorry. 0 who? Which is, so that 8 pi was huge. But in perspective, was it huge for percent error? No, because maybe area was like 500 pi, and I'm off by only 8 pi. Is that bad? No. But when I first said 8 pi, did it sound bad? Man, I was off by 24. But if you said 1,000, give or take 24, is that bad? Well, that's actually pretty good. Okay. But if I said, oh, it's 4, give or take 24, is that good? No. Okay. One more, and then done. You have like 15 minutes. Okay, measure the base and altitude of a triangle R. And I bet this one will go better. Okay, I really do. So I have a triangle. And height. And base. And area. 1/2 base times height. Okay. Here's where your flaw is if you do it your way. There's 2 variables. You agree? If I did dA, D who? Give me one. H. Who will I get out? We'll get dB, right? Because the variables agree. Now, does the H variable agree with DH? So then you would get DH over DH, which is 1. So do you see that's bad? I need DH as well. Okay? But what happens if you do dA, dB? Who do I get? I'll get DH, but no dB. See how there's an issue there? Okay? What about if I do dA, dt? Who do I get? I'll get dB and dH. So that's the way I got to go. So here we go. Area was 1/2 base times height. D dt. What rule's on the right? Product rule. U is 1/2 d. What's the derivative? 1/2 dB dt. V is h. What's v prime? dH dt. So I got, what's the left worth? dA dt equals 1/2 dB dt H plus 1/2 B dH dt. Is the case? Yeah, just. No, because I think you could. No, you would, if you said like H was over 2, I'd still keep it as a product rule. Because instead of over 2, I'd think of it as 1/2 times. So instead of H over 2, is that the same as 1/2 times H? See how that's a product rule instead of H divided by 2? Okay. Okay. Now what? Times dt. dA equals 1/2 B dB H plus 1/2, 1/2 B dH. You have every piece. Could you plug in? Now will you go the dt way? Because if I throw in a random variable, if you don't want to make it dt, could you make it dz? Would then every guy pop out? But if you ever pair up variables, like when you guys said, let's do dh, what would this be if this was ddh? 1. Do you see how I lost the dh? Okay, better? Okay. Here's homework somewhere. And there's the homework. Remember, look at Blackboard to make sure you know what everything we're doing is for the weekend.